Hello, today we are going to discuss about connection in WANs, the connection which we are used in wide area network to connect the devices. So here in this we will learn about the T carrier connections like T1 and T3 lines and the fiber standards SGH and the SONET and the packet switching protocol like frame relay, X.25, ATM and MPLS. So let's discuss about these in detail. So the first of all we will discuss about the T carrier lines. So these T carriers are the series of wideband digital data transmission formats. So these T carriers was developed by Bell Systems and it is commonly used in North America and Japan. So this is the standard which are basically used in North America and Japan to transmit the digital data over these T1 or T3 lines. So these T carriers are the dedicated high-speed lines and its basic unit of the T carrier is DS0, that is digital signal 0, and this DS0 converts the analog sound or the analog signals into the 8-bit chunks or the 8-bit data streams. So the speed of the DS0 is 64 kbps. So let's first discuss about the T carrier level 1 or the T1 line. So this T1 is a dedicated phone line that are leased by various offices usually on the monthly basis. So these T1 lines use special signaling methods called digital signal 1 DS1. So this DS1 is a primitive frame which consists of 25 pieces. So here the 25 pieces indicate one framing bit and the 24 channels. So it consists of one framing bits and the 24 channels. So each DSN1 channels holds the 8-bit DS0 data sample. So here the 24 channels have every 24 channel have the 8-bit DS0 data sample. So framing bit that is of 1 bit plus data channels that are 24 channels. Every channels have the 8 bits, so 24 into 8 will give 193 bits per DSN1 frame. So the transmission rate DSN1 frame is transmitted at 8000 times per second, giving a speed of 1.5 Mbps. So the T1 lines transmit the data at the speed of 1.5 Mbps. The next T carrier level 3 or the T3. So these T3 lines are the upgrade version of T1 lines and these are using the DS3 lines. DSC signal, that is digital signals 3. So it supports data rate up to 45 Mbps and it consists 672 individual DS0 channels. So here the quantity of DS0 channel is increases, that it consists 672 individual DS0 channels. So it is used by the ISPs to connect to internet and regional telephone offices. The next is the T1 and T3 and E1 and E3 carrier line. So here we have shown that T1 and T3 lines are the lines which are used in North America and Japan, whereas E1 and E3 lines are the European lines which are used in European countries. So here the speed of T1 line is 1.544 Mbps, whereas the speed of E1 line is 2.048 Mbps, whereas the speed of T3 line is 45 Mbps and the speed of E3 lines is 34 Mbps. Here the channels which are used by T1 is 24 and E1 use 32 channels, whereas the T3 use 672 channels per DSN1 signal, whereas the E3 line use 512 channels. So this is the difference between the T1, T3 and E1, E3 lines. The next is the channel service unit, digital service unit, that is CSU or CSU, DSU or CSU. So this is a component which is used in the T carrier connection. So it is a link point which goes from phone companies to the customer equipment. So it performs functions like encoding of data and also it performs the function like loopback testing. So it consists of connectors we use to connect the T1 or the T3 lines, and it also protects the user equipments from lightning strikes and the other electrical interference. So this is a component which is used in the T carrier connections to connect the T1 or the T3 lines. The next is the fiber optics or the fiber cables. The fiber optic cables is made from strand of glass fibers that use pulses of light to transfer data. So here we transmit the light data in the form of light and in the strand of glass fibers. So these fiber cables are basically designed for long distance communication, and the first standards which is used in fiber optic cables to transmit the data are SONET and the SDH. SONET stands for synchronous optical networking and SDH is synchronous digital hierarchy. So these standardized protocols are used to transfer multiple digital bit streams synchronously over a optical fiber. So these standards replace the PDH, that is pleiosynchronous digital hierarchy standard, which is used in the earlier telephone system. So this PDH is a technology used to transmit large amount of data over digital equipment such as fiber optics and the microwave radio systems, but it transmits the data asynchronously, means the data is not synchronous between the transmitter and the receiver. So that's why we jump up to the synchronous transmission, that is SONET and the SDH. So the difference between SONET and SDH is that SONET is developed by US through ANSI T1X 1.5 committee, whereas SDH is developed by ITU, that is International Telecommunication Union. This SONET is a subset of SDH because it is developed after SDH. So here we use the basic unit of SONET. We use this optical carrier level 1, that is OC1, which gives the speed of 51.84 Mbps. So this is the speed which is given by the OC1 lines. Whereas in SDH, the basic unit is the STM1, that is synchronous transfer module, which we use to transmit the data with a speed of 155.52 Mbps. So this is giving the speed of 155.52 Mbps to transmit the data over SDH frames. So here the type of optical carriers are OC3, OC12, OC18, OC24, OC36, OC96 and the OC192. The latest version is OC192. So these are the optical carriers and each having the different speeds, whereas the type of STMs are STM1, STM4, STM16 and STM64. So these are the types of STM frames. So these the SONET is used in America or Japan, whereas the SDH is used in European countries. So this is the difference between SONET and the SDH standard. The next is packet switching protocol. So here the fiber cables use packet switching concepts to route the packet in the network. So the first generation of packet switching protocol is X.25, which was developed by CCITT. So it is the International Telegraph and Telephone Consultative Committee which developed the first standard for the packet switching, that is X.25. So here the form of packet switching protocols are frame relay, asynchronous transfer mode, that is ATM, multi-protocol label switching, MPLS and also TCP. So in this we will discuss about three: frame relay, ATM and MPLS. So let's first discuss about the frame relay. So the frame relay is a fast and efficient packet switching technology with low chance of transmission error. So it transmits the data fastly. So it is designed to use with the T carrier lines and it was used to connect LAN and WAN networks. So it works over the layer 2 of an OSI model, that is the data link layer of an OSI model. And here the frame relay designed to transmit data quickly over the transmission medium as possible over low error network. So it also check the data that it is error free or error is coming in the data. So this was the frame relay packet switching protocol. The next protocol was asynchronous transfer mode, that is ATM. So ATMs, it carry the user traffic such as voice, video and data over a one connection. So here it encapsulates these voice, video and data and it transmits over one connection. So it also works at the layer 2, that is data link layer of an OSI model, and network technology which was designed for high speed LAN. This technology was designed for local area network transmission between a local area network but widely used in the WAN, wide area network. So before it was used in SONET. This technology was used in the SONET network, but now MPLS is used in the SONET. So the ATM is the core protocol used in PSTN and the ISDN network, that is the older technologies. So the speed which is supported by ATM is 155.52 Mbps to 622.08 Mbps. So these are the speed which is supported by the ATM, and it uses the asynchronous time division multiplexing. It means the data is not synchronous between the transmitter and the receiver. So it encodes the data into short and fixed length cell. That is, the length of the cell is 53 byte, and it divides the frame into data, short length data, and transmit over the transmission medium. So ATM can support different transfer speed and the requirements. The third standard is the multi-protocol label switching, that is MPLS. So the MPLS is a type of data carrying technique which use high performance networks. So MPLS is a scalable protocol independent transport. So data packets are assigned labels before sending over the transmission medium. So packet is routed according to the assigned labels rather than accessing complete network address. So here the packets are routed in the network, and because they are assigned with the labels, and they are identified with the help of these labels, and it replaces the frame relay and the ATM technologies which are used in previous transmission mediums. So MPLS works at the layer 2 and layer 3 of an OSI model, that is, it works over the data link and the network layer of an OSI model. So here the MPLS can encapsulate packet of various network protocol or the different network protocol like T1 or E1 lines or ATM, frame relay, and DSL. So the MPLS headers consist of 4 parts, that is label, cost of service COS, single packet, that is denoted by S, and time to live TTL. So here let's discuss about the label. So this is a unique identifier which indicates how to move the data in the network. The next is COS, that is cost of service. It tells the cost of the service which is used in the network. Whereas the single packet, as single packets have multiple MPLS label, so the single bits value is set to 1 for the initial labels. So TTL, it determines the number of hops traveled by the packet or number of intermediate devices traveled by the data packets. The next is the terms which are used in MPLS network. So first term is forwarding equivalence class, that is FEC. So it defines a group of devices that send the packet in a single broadcast domain. So this forward equivalence class define the group of devices which sends the packets in a single broadcast domain. So the next is label switching router, that is LSR. So this router forward the packet according to the MPLS label, whereas label edge routers, LER, so these routers add the MPLS labels to those packets which don't have this label. So they are only used to assign the labels to the packet. Whereas label distribution protocol, LDP, so here the LSR and LER use LDP to communicate about the dynamic state. So these are the terms which are used in the MPLS network. So this is all about packet switching protocol. Thank you.